Alright, my guys, it is time to do our routine checkup on USACO. Let's go. I know Amy's coming up this Wednesday, but like, I don't think I have time to make more math videos. And I've already made like 4 math videos in like the past 2 weeks, so I think we're good there. Okay, I do have to take the Amy practice test, but we'll see if I can record 3 hours. I don't think I want to record 3 hours, but we'll see. We will see. Hello, everybody. I'm Karar, and today we are going to be talking about USACO 2021 February contest bronze. Very cool. One of you guys wanted me to do one of the questions, but I always do all the questions, guys. Chillax. I will get to it. Don't worry. So let's do it. Alright, number 1, year of the cow. Farmer John's cows are excited to learn that Chinese New Year is recently celebrated. Hey, nice. The year of the ox, okay. All the way to vote. As we know, the Zodiac animals are these boys. Okay, seems irrelevant. Bessie the cow is proud to say that she was born in the year of the ox. Alright. And how many years apart from Bessie she was born? And okay. So, first line contains N, right? And then the next contain the 8-word phrase. Okay, bro, this is so troll. Okay, let's see. In the previous dragon year from Bessie. So Bessie was... Oh, I see, okay. So essentially the only words we care about are next, Mildred, Dragon, and Bessie. Okay. Alright, so, alright, we got that. Oh yeah, okay, it literally says. Okay, and basically you want to do that. Alright. So, I mean, this just seems like stupid logic, but there's gonna be cancer to the program unless we think of a smart way to do it. Okay, so, Bessie, we know, right? Okay, so we're all doing relative to Bessie, right? So, if previous dragon year, we basically, like, take ox and we see when the previous dragon year is, then if Mildred. Well, okay, so directly from this, we could get like a difference between Bessie and Mildred. Each one gives you a difference between one guy and another. And then, based on the differences, we could just travel from Bessie to Elsie and hope it works. Is it guaranteed that we'll be able to find it? Yeah, okay, so it's guaranteed that it could be determined, so we should be chilling. Alright, so basically, we'll keep like an array of like all the random things, ox, tiger, etc., right? And then we'll map them each to like a, to an index, right? So ox is 1, right? I mean, ox is 0, right? And then what would dragon be? So dragon would be 0, 1, 2, 3, so it would be 3. What would monkey be? Monkey would be, counting is hard, dude. 3, 4, 5, 6, 7, alright, 7. And then what is next? Ox. Ox is 0 again, and dog is, what is 11, 10, 9, 8. Okay. Wait, what? How does that work? Okay, 0, 1, 2, 3, 11. Oh, yeah, okay. So this is 11. 11, 10, 9. So 9. Dog is 9. Alright. Okay, so if she's in the previous dragon year, you're going from 0 to 3 backwards, so it should be minus 9, right? And then if you're going from previous, so B to M is minus 9, then M to G, if you're going from monkey is what? Monkey is 7. And you're going from dragon to monkey. So you're going from 3. Oh. Okay, so it's guaranteed that it's mentioned in the previous line. Okay, yeah, so that's fine. So M to, so 3 to 7, right? So that's like 15 to 7, which is minus 8, right? M to G, then G to E is going to be next ox here. So you're going from 7 to 0, which is plus 5. And then B to P. And we're trying to find Elsie, right? Okay, so we could just ignore this. So if we add this all up, we get minus 9, minus 8, plus 5 is negative 12. And it wants the positive difference, I'm assuming, so we just take 12. Very cool. Epic. Alright, this is going to be Canada Dakota, though, so hopefully we find a smart way to do this. Alright, what are we going to call this boy? Zodiac, why not? Zodiac seems legit. What are we going to use for this? Why don't we use Python? Because Python is fun for bronze problems. Actually, you know, why don't we change it up? I think we did Python last time, right? Yeah, why don't we do C++? Alright, so we first gotta have our int m, and then we got to have what do you want to do? So we want to store like relative to Bessie. Yeah, we only want to store relative to Bessie and like what year they are, like which index year they are. So we'll do like year, or what? We'll do int year, and that's basically for all of these guys. So so the names are whack. The names could be anything, right? Okay, so then we should probably use map here, which is basically a Python dictionary. So map string int. Oh no, we're good. Using a namespace, and then we also want to map the name to their relative to Bessie. So let's call it say rel. Okay, so we first see an n. And then for int I equals 0, I is less than n, I plus, and we should probably have a, a year to, string to int map of year to number. Okay, so we'll first have a array. Let's say like string Zodiac, or let's say Zodiac 12 is equal to tiger. And we'll type out all this epicness. Very cool. Bro, why do they gotta do this to me? God dang it. Okay, well, we finally did it. Okay. And then at the very beginning, we will like just go through the Zodiac and make a map from string to map string int vin. How about that? And at the beginning, we will just go through for int I equals 0, I less than 12. We'll basically just set vind of Zodiac I is equal to I. Okay, so how many words are there? There are, it says the last word. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. So we'll basically have a string first, string second, or let's say string A and B. B or prev, and what else do we want? We also want year. Okay. And then we will just cin A, then for int, like, I don't know. Well, how do you just like I equals 0, I less than 3, I plus will cin prev. Then we will cin year, and then and then we'll just for int I equals 0, I less than 3, I plus cin b. Okay, so now we should have our a, b, prev, and year for each one, and now we can do our epicness. Okay, so we'll take like int year a is equal to like, I don't know, Zodiac 1, 2, or sorry, no, Zodiac of the A guy. Wait, no, what? No, so year A is equal to it should be year, okay. Sorry, Zodiac, sorry, it should be Zin of year, okay. And then into year B is just equal to year B, okay. Okay, that should be fine. I don't know why it's saying an error, but hopefully it works. Actually, why don't we just test it? C out A, B, prev, year. Okay. Wait, what? What's the difference between the end and year? I'm reusing year. Okay, so say YR. How about that? That makes so much more sense. Bruh. Okay. So we get, we should probably do an endl to make this a bit more clear. Hey, okay, nice. So we got Bessie, previous dragon. Alright. What? Why did it not print Mildred? Oh, it did. Yeah, okay. We're good. We are chilling. Okay, so we basically got the 2 years, right? And if it's previous, then you want to take, like, subtract the 2, and then, like, add 12 if necessary. Okay. Okay, so then we'll basically say, if, like, prev is equal to previous, that means that, like, we want, okay, so year A is this dude, and we basically want to go backward from year B to year A, right? So we would do year B minus year A, so int diff is equal to year A, or year B minus year A plus 12, and then mod 12. And we basically just set, so we basically set, what? We set year of A is equal to year A, and we set rel A to equal rel B minus diff. Is this right? It should be right. Okay. So, if you do like, if you're going from what? We were going from 0 to 3, then we would do 0 minus 3 plus 12. Okay, yeah, that's right. And then otherwise, we would do int diff is equal to year A minus year B plus 12 mod 12, and we will do the same thing here, except we do plus diff. And at the very end, we want to print out what LC is. So we'll just do cout, is there an abs of rel LC. Alright, let's test this out. that was not too bad, but we'll see if it works. 12, hey, very nice. Okay, we will see if this works. Let's try it out. Hey, it seems like it's working. Oh, nope. Okay, did I? Hold up. Oh, I see. So if they're the same, if diff is equal to 0, so if it's 0, we don't want to, okay, so let's say this is 0, right? Then we add 11 mod 12 plus 12. No. So it should be 12 at the very end, plus 11 mod 12 plus 1. How about that? Okay, then if it was difference 1, then you would add 11, it would go to 0, and then you'd add 1. Okay, so that should be fine. Add 11 plus 1. So basically what this does is it just shifts it from going from 0 to 11 to go from 1 to 12. So this should be fine, and we should probably do that for the other one too. Year A minus year B. Alright, now this should work, hopefully. Let's see. Hey, okay, nice. Alright, very cool. Let us move on to problem number 2. Comfortable cows, epic. Alright, Farmer John's pasture can be regarded as a large 2D grid of square cells, okay. Initially, it is empty. That's so sad. Farmer John will add N. Okay, 10 to the 5, that's pretty fat. Cows to the pasture one by one. The ith cow will occupy a cell X, okay. And it's distinct from all the other ones, okay. So essentially, it is comfortable if it is horizontally and vertically adjacent to exactly 3 other cows, and Farmer John basically wants to know how many comfortable cows there are on his farm. Alright. Okay, so, basically how this works, let's draw it out. We basically got, like, our epic grid. That's not a grid. Like that. And basically we keep adding cows, right? And eventually one of them is going to be like, or exactly 3 other cows. Okay, so eventually one of the cows is going to become like comfortable, and then we would print out 1, right? Before that, all of them are not comfortable, so we print 0, 0, 0, and then we get to 1 comfortable, then we print 1, so on and so forth. And then if we pull it in here, then we have to go back down to 0, right? Okay, so I think the basic idea for this one is like, when you add a cow, it can only affect the comfortability of, is that even a word? I have no idea. The comfort. Dude, I forgot how to English when I'm doing USACO, that's so sad. But basically the idea is you can only affect like the guys who are next to you, how comfortable they are. So essentially you only have to check four other dudes every time you add a cow, and you just check whether they become comfortable or they become uncomfortable, and then you're good. Okay, let's do this. Comfort. Alright, using a namespace. Int n, alright, and we'll have our, well, we don't even need, because we're just doing, okay, so we should just keep track of how many adjacent dudes. So you're only adding, right? So the number of adjacent dudes can only go up for each person, right? So we'll just have like adjacent. Yeah, we don't even have to keep track of which ones are already there, right? Oh no, you do. Wait, what? Yeah, you probably, okay, let's just have like grid in bool grid. Yeah, bool grid. How big? 1000 by 1000. Let's just do 2000 for coolness. And then we could do add. Wait, do we even need this? Wait. We could just do add, like, add, okay, yeah, we just call it add, and then that will store how many people are adjacent, and we'll set it to -1 originally if there's nobody there. Okay, so we do cnn, we do for int I equals 0, I less than, or what is, no, what, that doesn't matter. Okay, so I equals 0, I less than 1000, or less than or equal to 1000, I plus, for int j equals 0, j less than equal to 1000, j plus. And we'll just say add ij is equal to -1. Okay. Okay, so now every time we add, let's make our type def thing. Type def char int pii, okay. 0 I less than n, I plus, and we'll do pii xy is equal to, or that, and then just cin xy dot first, xy dot second. Okay. So the first step is literally just to put it in the array and like add 1 to all of it, right? Add 1 to itself, right? Because it is no longer -1, and then you add 1 to all the ones around it, right? Okay, do you want to do that? Well, okay, first we had to set our own add, right? So we'll basically count, so for int I, or let's do an add array. So basically an array does to store like which way we go. So we'll do like int oh, why don't we call this grid, and then we'll call this add to make more sense. And basically this will just tell us the tuples that we need to apply, so we'll probably need pii, and we'll have 4 of them, right? Because you could go right, left, up, or down, and we'll say 0, 1, 0, -1, 1, 0, and I almost forgot, -1, 0, very cool. And essentially we'll just go for int pii n, or next, in add, we'll basically say, like, I don't know, next x is equal to xy dot first plus next dot first, and next y is equal to xy dot, or is equal to xy dot second plus next dot second. So if like if like grid next x next y, or we should probably keep track of int total of 0. If that is greater than equal to 0, then we basically do total plus plus. And then we just increment grid next x next y by 1 because we're adding a dude next to it. Okay. Oh, so yeah, this should be an int. And then over here we basically just say grid, let's see. Okay, so okay, so if grid next x, okay, so we should have keep like a running total of how many are comfortable right now. So int comfortable equals 0, and then over here we'll say grid x dot xy dot first, xy dot second is equal to total, right? Okay, so now if our total is equal to 3, then we want to add another comfortable dude. If total equals 3, then we want to do comfortable plus plus, okay? And also if like, okay, so the new guy that we add, like the adjacent guys could have changed, right? They could have become uncomfortable or they could have become comfortable, right? So we basically do the same thing over here. We could probably just do it here. If let's see, if like, I don't know, if grid next x next y is equal to 4, then we do comfortable minus minus. Else if grid next x next y is equal to 3, then we want to do comfortable plus plus. Okay. And also we want to check that our next x and next y are not outside of the grid. So we will do let's see, if what? If next x is greater than equal to 0 and next x is less than equal to 1000, and you guys get the idea. And then basically after each of these we basically just do cout comfortable. Alright, now this should theoretically work. The idea is there, but let us see if the actual legitness is there. I very doubt it, but we'll see. 0001 0012. Not bad. Alright. Good stuff. The USACO gods are being pretty nice to me today. Well, actually, we will see. Are they gonna be nice? Hey, they are being nice. Alright, let's go. Hey, we did number 2. Let's go. Number 3. Alright. By the way, it is not normal for me to not have any bugs so far. Actually, I did have a bug in the first one, but we don't talk about that. Alright, Clockwise Fence. The fence surrounding Farmer John's largest pasture has fallen into disrepair, and he has finally decided to replace it with a new fence. Very good for him. Unfortunately, as Farmer John is laying out the new fence, a large bee ends up chasing him around the pasture, and as a result, the fence ends up following a rather irregular path, I would imagine. The fence can be described by a string of characters, either n, okay, each character, okay, the fence ended at the position where it started, and this is the only point visited more than once by the path of the fence, and it's only revisited once, okay. As a result, it encloses a single connected region, and he wants to see if he laid it counterclockwise. Oh, okay, yeah, that makes sense. Okay, so they did basically give you a ton of fences, and then you want to see if each one is counterclockwise or clockwise. Okay, so let's see. I think this is troll, but I'm not exactly sure. But basically, you could either start your fence going this way, this way, this way, or this way, right? So let's just say, like, for example's sake, that you started going this way, right? Then there's no way you're gonna come back here and go there, because the only one that's revisited twice is the starting point, right? So you can't come from here, but you could come from there, right? You could come from there. You could come from there. Do we know whether it's clockwise or not? Just based on this? No, we do not. Okay, so I guess it's not that troll. Huh, so that's actually pretty interesting, huh? Yeah, I've never done a question like this before. That's kind of cool. Okay, let's see. So how do you figure out if you're going clockwise or counterclockwise? So it encloses some area, right? So either the area enclosed could be here, or the area enclosed can be there. But how do you find area enclosed though? Okay, let's just think. So essentially, if you make a counterclockwise turn, right, then your area is going to be counterclockwise, right? So what happens if you took like a right turn here? Then if you wanted to ever make it counterclockwise, that basically means you would have to turn more. Okay, let's see. Okay, is there a way to make it counterclockwise but turn more times clockwise? So you had to at least turn once counterclockwise, but if you turn clockwise twice, then the only way to like not the only way to make it counterclockwise is if you turn counterclockwise at least as many times, right? I'm like 25% sure, not very sure, but I'm pretty sure that if you turn counterclockwise more times, then the area is counterclockwise. Because there's literally no way to get the area to be clockwise if you turn counterclockwise more, right? But there might be an easy way to do it, let's see. Okay, also, like, the note intersections, right? So, the no intersections, right? So even if you turn counterclockwise as many times as you want, there's literally no way to get like out of this side of it without turning counterclockwise, right? But, well, yeah, you would at least have to turn counterclockwise enough. Well, yeah, because basically, like, yeah, because basically, like, you have to, for every clockwise turn, you have to make a, like, you gotta mirror it, right? Like that. So this mirrors that, right? Okay, is that even true though? I'm pretty sure though. I'm pretty sure. If we just count the number of clockwise and counterclockwise things we'd be done. But I'm trying to think if there's an easy way to explain why that works. Yeah. Okay. Yeah. I'm pretty sure that is the solution. So we'll just count how many clockwise turns he makes, how many counterclockwise turns he makes, and we should be good. Okay. Like, let's just test it over here. So, like, over here, it's pretty clear that you make only clockwise turns, so that's why it works. Alright, so here you make one counterclockwise, alright, another counterclockwise. What? Oh, another counterclockwise, so that's like 3 counterclockwise, 4, wait, so 1, 2, 3, 4, 4, 1, 4, 2, 4, 3, 5, 3, 5, 6, 3, 7, 3, 8, 3, 8, 4. Yeah, okay, so it seems legit. Alright, let's code that up. Alright, using namespace, int n, and we'll basically just go through each of these dudes. So, cnn, and then for int I is equal to 0, then we'll basically just do string s, cns, and for int j is equal to 0, j is less than s.length, j plus plus. Okay, so essentially we want to keep track of our current direction, right? So we'll have like int or car dir is equal to, I don't know, we'll put an empty character for now, I suppose. Okay, we'll probably put something. Let's see. Let's just do a not. Okay, so let's see. Let's say if dir is equal to that, then we'll set dir equals sj, and we'll continue. Otherwise, what do we want to do? Otherwise, if okay, it's always 90-degree turns, right? Yeah, okay. If dir is not equal to what? Huh, why don't we, okay, let's just do this. So we'll have a what? How do we do? Okay, we could do like, I don't know, int dir to num, okay, and we'll take in a car, and we'll just do switch c, and we'll do case n, return 1, and we'll name them in clockwise order, okay? So north, then we go east, all unindent at the very end, I guess. Case south, return 2, case west, or return 3, okay. And we should probably put a break over here, and 0, okay. So essentially, if the number is greater, right, or it's like if you take the number, you subtract it, and then it's like mod 4 or whatever, or well, basically, if there's a difference of -1, then you are basically going counterclockwise, and if there's a positive difference, then you're going clockwise. Okay. So if dir is not equal to sj, then we actually care about it. So we'll keep track of int cw equals 0 and int ccw equals 0. Let's see. Alright, so I guess if dir to num dir is what? Minus sj plus 4, mod 4, is equal to 1, then is equal to 1, then we do cw plus plus, okay, and otherwise we'll do ccw plus plus, and we'll set dir is equal to sj. And then at the very end, if cw is greater than ccw, then we see out cw and l, and otherwise we see out ccw and l. Okay, let's test this out. Did I get it backwards? The heck? Okay, so north to east, right? So, oh, I did it backwards. Yeah, okay, so this should be 3. Okay, clockwise, counterclockwise seems legit. Let us test it out. Alright, let's, a moment of truth, please. I have a very bad feeling about this one, though. Oh, it works. Okay, nice. Epic. Alright, thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. This one went pretty smoothly. I'm not gonna lie. But if you guys have any questions, let me know down in the comments. If you guys have any suggestions for what you guys want me to do in the future, let me know down in the comments. But other than that, thank you guys so much for watching again, and see you guys next time. Oh wait, one last thing. I will probably get to Silver or Amy for walkthrough. We'll see what we do soon. So look forward to that. Alright, now actually, see you guys next time.